few laws of exponents. These laws are very important in algebra. It will help you to be able to solve problems with ease once you understand all these laws. The first law we're going to go through is a law we use when we're multiplying. So it goes when you have a to the power of m times a to the power of n, whenever the bases are the same, then you must add the exponents, okay, during multiplication. So our answer is going to be a to the power of m plus n. So if we have a to the power of m divided by a to the power of n. So as with multiplication, what is important is for the bases to be the same. If the bases are the same, then in division, we subtract the exponents instead of add them. So our answer is going to look like a to the power of m minus n. If we have a bracket where we have a and b, which are two separate variables, raised to the power of n. So the rule goes that you raise each and every single entity in the bracket to the power of n. So our answer is going to look like a to the power of n times b to the power of n. The next law is similar to the previous one, just that there's division involved this time. So in a bracket, we would have a divided by b raised to the power of n. So the same law applies. Every entity within the bracket is going to be raised to the power of n. So we're going to have a to the power of n divided by b to the power of n. An interesting fact here is to note that the inverse, when you have 1 over b to the power of n, this is simultaneously equal to b to the power of negative n. So now our answer here can be a to the power of n times b to the power of negative n. When we have a to the power of n bracket raised to the power of n, right? So in this case, the rule says you multiply these exponents with each other. So our final answer is going to be a to the power of m times n. Example is where we have k squared times k to the power of 3x minus 4 divided by k to the power of x. So now we're going to start at the top, simplify the top, and then simplify the entire expression. So we start by saying, as we can notice that the bases are all the same, so that's when we work with the exponents where we add and subtract exponents. So at the top, we're going to have k squared plus 3x minus 4 divided by kx. Moving on, we have now at the top, we're going to have 2 minus 4 gives us negative 2. So it's 3x minus 2 at the top divided by kx. So now we're going to apply our law of exponent that involves division. So we're going to bring up the k to the power of x, and then we're going to subtract the exponents. So we're going to have k 3x minus 2 minus x. Where now we can just subtract again the like terms where 3x and x are like terms. So we're going to have k 3x minus x is 2x minus 2, and that would be the final answer. Bracket 1 over 4 raised to the power of 0. So again, the rule says you'd raise everything in the bracket to the power of 0. So we're going to have 1 to the power of 0 divided by 4. to the power of 0. Now we all know that anything raised to the power of 0 is equal to 1. So we have 1 divided by 1, which then is equal to 1. In the next example, we have 3p to the power of 5 squared. Now here we're going to use two rules. The rule that says you apply the exponent to every entity in the bracket, and also where you're going to multiply the exponents with each other. So we get 3 squared times p 5 times 2. And then our answer is 3 squared is 9 times p to the power of 10. The last example we're going to do is where we have 1 divided by 1 divided by a to the power of minus 1, where we're going to raise every entity in the bracket to the power of minus 1, which gives us 1 divided by 1 to the power minus 1 over a to the power minus 1. So here is where we use the inverse rule again, where 1 is going to go to the bottom and a is going to go to the top. So we're left with 1 divided by a.